Okay, no problem. Right. So let me, yeah, let me start today's session. Okay. Now today's session is, so what we are talking about is about collections module, collections module. Okay. Collections module. We are talking about collections module here. It is one of the predefined module which comes with the Python software. You don't require to install this collections module. Is a default module which comes with the Python software. You don't require to install this collections module. Okay. So it is a default module. It is a default module which comes with Python software itself. Okay, it is a part of Python software. You don't require to install this. So it is a default module which comes with the Python software. So collections module, right? So module means it provides some predefined functionality and predefined data types, right? So the collections module in Python provides alternatives to built-in data types such as list, tuples, dictionaries, and sets. Already Python is having some collections. Yes or no? Okay, like list, tuples, dictionary, and sets. These are built-in data types provided by Python. These are built-in data types provided by Python. It provides additional data structures and operations that are more efficient than built-in data types. In certain situations, you are using some data structures provided by which one here collections module. Now there are certain things which becomes very complex when you're working with the list, when you're working with the dictionaries. So those operations can be simplified. Using data structures in the collection module. Now you can say collections module is an add-on. Collections module is what here? Add-on to the Python built-in data types. Python data types, right? So Python data types, when I'm talking about this, Python data types are classified into two, right? One is a standard. This together is called as built-in data types. Okay. Scalar types like integer, float, float, complex, integer, float, complex. Okay. And there is a Boolean, and so there is a none type. Okay. These are standard data types or scalar, which represent one value. So integer represent one value, float represent one value, complex represent one value, Boolean represent one value, and none type represent one value. If you want to represent multiple integers or more than one integer, more than one float, more than one complex number, then go for which data types? Collection types. Now Python provide inbuilt collections like list, list tuple, set, rows on set, rows on set, dictionary, bytes, and one more is byte, array, and string. So these all together you call it as inbuilt data types. But this data type represents individual values, and this data type represents what? Collection of values. Like list is a data structure or collection. Tuple is one data structure or collection. And set is one data structure and collection, rows on set, dictionary, bytes, byte array, and one more is a string. But apart from this, inbuilt data types, Python provide some more collections or data structures. But where those data structures or collections are available, okay, in one module called collections module. Okay, so it is a inbuilt module. You don't require to, okay, now install. Generally, if you want to work with other, you need to install. Like suppose if I'm working with, if I want to work with NumPy, I need to install NumPy. If I want to work with the pandas, I have to install the pandas. But here I don't require. I can directly say from, okay, or I can say directly import which module, collections module. So yeah, I installed anything here? No. I directly said import collections because it is a part of Python software. It is a part of Python software. You don't require to install this. Okay, you don't require to install this. It's a part of it. Okay, right. The next is, so apart from this, I said no, apart from these collections, Python provided some more collections which makes it, okay, okay, performing certain operations easily and more efficiently or more effectively. Okay, so certain things becomes very complex when you're working with the listed tuples set and frozen set. Then you try to achieve that in efficient manner by using data structures available in which one, collections. So what are the data structures provided by collections here? Now here these are these are the content of collections module. Okay, so you have a counter. So all these are containers. So here containers, list is a container, tuple is a container. Now continuation of this, like there is a counter. So there is a counter, and second one is ordered dictionary. Third one is default dictionary. Okay, and fourth one is chain map, and fifth one is named tuple. Sixth one is DQ. Seventh one is user dictionary, right? Eighth one is user list, and ninth one is user string. See here. So already in regular class, you have learned might be this list, tuple, set, frozen set, bytes, dictionary, and byte array and stringer. Now you are learning more collections. Okay, more number of collections or data structures like counter, ordered dictionary, default dictionary, okay, chain map, named tuple, DQ, users list, dictionary, user list, and one more is user string. So within this, first we'll be talking about counter. So we'll talk about which one? Counter. The name itself, right? So we'll be talking about counter. Okay, so first we'll see, okay, what is counter? First we'll see what is counter. Then we'll see why we should use a counter. Okay, so what is counter? The name itself, right? So Python counter, okay, is a collection, right? Python counter. Python counter is a container. So container means collection. Python counter is a container. Container means collection. Container. What container is having? Okay, container contain one or more than one object. Container is having one or more than one object. So Python counter is a container that hold, okay, that hold how many values? One or more than one value, more than one value, which is called as count of. count of which one? Objects. Python counter is a container that hold a count of objects. Count of objects. Okay. Count of objects or element or objects exist in, or you can say count of objects, count of object. Okay. The number of objects exist in other containers. Okay. You can say Python counter is a container that hold count of objects. Okay. So that is nothing but it will return. Okay. It will return, or it is having count of each and every object exists in other containers. So the counter is a subclass. Okay. The counter is a subclass. The counter is a subclass. Subclass means you know it, inheritance. Okay, so dictionary is a parent class and counter is a child class of dictionary class. The counter is a subclass. Okay, counter is a subclass. It is a subclass of a, it is a subclass of which one here? Dictionary. Counter is a subclass of a dictionary, right? Okay, it is a subclass of, the counter is a subclass of a dictionary. Counter is a container that hold count of objects. That hold count of objects. The count, say the counter is a subclass of dictionary that hold count of objects. Then why counter is the name itself, right? Okay. Why counter is, okay, the name itself. It is used to count. It allows you to count the items in iterable. Okay. It is used. Okay. It is used to count. It is used to count items available or exist in what here? Iterable means all collections are called iterables, which allows to iterate or which implements iteration protocol are called which one here? Iterables. It is used to count items available or exist in iterable. Iterable is a collection or iterable which implements iteration protocol or which allows to read individual objects that are called as which one here? Iterables. Okay. So why counter is for counting items are available or existing iterable. Okay. Not only that, counter. On counter, even you can perform arithmetic operations and even you can perform some set operations. Okay. So counter allows to perform, perform arithmetic. So arithmetic and set operations, arithmetic and set operation. Okay. So counter represent data as a key and a value because it is a subclass, right? So counter represent, okay, counter represent data as a key and what is that? Value. Okay, as a key and value. So here this is, so what is a counter is? So counter is a container that holds a count of objects. Counter is a subclass of which one? Dictionary. Why counter is? It is used to count items available or existent iterable. Counter allows to perform even arithmetic and set operations. And counter represent data as a key and value, right? Then how to use this counter? Suppose I said counter is for counting. It means you can use a counter. So counter can be used with, counter can be used with any iterable. Any iterable which implements which protocol? Iteration protocol. Yes, it can be used with any collection. This counter can be used with any collection, right? For example, any collection. Any collection means, so counter can be used with, okay, yeah, you can use a counter with a list. You can use a counter with the tuple. Okay, you can use a counter with the, what do you call it, as string. You can use a counter with the dictionary. You can use a counter with what, set, like this. You can use with all collections. You can use with all the collections. You can be used with all the collection. So what is the syntax of this? Okay, you try to use a counter. Yes. What is the syntax of using counter? Counter, it followed by which one here? Iterable. Now this syntax return counter object. This syntax returns which object? Counter object. Okay. For example, okay, I just say here, from collections import counter. Okay, so I imported counter class. Then for example, I have a list. List is there with some values. So there are some values in the list like this. Okay, there are some values in the list. I try to put some values in the list. All these are the values exist in the list. Now I want to know, I want to count how many times each values exist, right? I want to know how many times each values exist. Suppose I want to know how many times one is there, how many times two is there, frequency. Now this is useful when you're working with statistics. I want to count how many times each element is there. Okay, how many times one is there, how many times two is there. It's called as a frequency count, right? Then how can I find out? Suppose if a counter is not there, suppose if the counter is not there, what you have to do is you have to convert this list into what you have set. You have to, if the counter is not there, see, assume that if counter is not there. So as a Python developer, what do? You convert this list into a set. You convert this list into a set. Then after that, you just read each, because why you are converting list into a set? For removing duplicates. For removing what here? Duplicates. And then every time you read one value from where? Set, and then you count how many times that value is there in list. Then I just display format. So what I'm displaying here, value. Along with that, I'm displaying list one dot, what is that? Count of value. List1 dot count of value. Okay. So I'm printing value and how many times that value is there. Okay. Yes, if you run this, now one is there how many times here? One time. Two is there three times. Three is there two times. Four is two times. Five is four times. Six is three times. Seven is three times. Eight is three times. Nine is what here? Two times. But this much code I have to write it in order to count. This much code I have to write it in order to count how many times each value is there. But by introducing this counter, you don't require to write this much of lengthy code. So what you can do, you can simply, what you can do is you can simply use counter and just write here C equal to counter. So counter of, I just write here list. Okay, counter of list one. Once you say counter of list one, and if I print count here, now you can see 5 is there how many times here? 4 times. And 7 is a 3 times, and 8 is a 3 times, and 2 is a 3 times. Now it is stored as a key and value, as counter is what? Dictionary is a subclass of what? Dictionary. Sorry, counter is a subclass of what? Dictionary. So 5 is a key. Key is nothing but, in this case, 5 is a value, and 5 is there how many times? 4 times. 7, 3, 8, and 3, because it is hashables, and hashables are not ordered. Hashables are what here? Unordered. So because of that, it is displayed like this. Okay, 5 is counted and added value as a 4, and 7 is counted and added value as what? 3. If you want, you can read this key and values by using for loop. You can read this key and values by using which one? For loop, right? Yes. Now you can count it, not only on list. Okay, it is not only applied on the list. List can be of any type. So don't think that list should be only contain integers, right? Okay. For example, I created one list. I created one list with some strings here. Okay. So I created a list with what here strings. For example, I just write some Python. Okay. Then Java. Yes. I'm writing some .NET. And again, I'm writing some Python. Okay. Again, I write a Python and then Java and then Python like this. Okay. Now this is a list contains some strings. This is a list contains some strings, right? I want to count how many each string is exist how many times. So this is useful in statistics, right? So how can I count it? I can simply, what I can do, I can simply, okay, what I can do is I can simply say C equal to C equal to counter of which one? List 1. When I say C equal to counter of list 1, now you can see C, and the Python is 4 and Java is a 2 and .NET is a 1. So can you iterate each item of counter? I'm saying for item in counter. Okay, then I just display what here? Item. But is item is a key or value? Key. If you want a key and value, then take some A comma B. It is a subclass. And how can you get the key and values from the dictionary? Items? Okay, then I just get key and value. So Python is a key and 4 is a value, and Java is a key and 2 is a value, and .NET is a key and 1 is what here? Value. Okay, so you are counting it. Okay, so even it is not only applied on the list, it is applied on any iterable. It is not only on the list, it can be applied on any iterable. Any iterable means, for example, I have a string. For example, I have a string with the ABC and ABC and ABC. Okay, some D and E. Right now, this is a string. I want to count the frequency of each character. I want to know the frequency of each character, right? I want to know the frequency of each character. Yes, all of you are getting or not what I'm telling you? All of you, yes, online students, right? The people are there. Yes. Okay. Yes, are you getting or not what I'm telling you? Yes. Okay. So this is, yes. Okay. Okay, right. Okay, right. Fine. Okay, so I want to count the frequency count, like how many times A, how many times B and C. Then what will I do is I'll just say C equal to counter, C equal to counter of, And what is that here? str1. If I say C equal to counter of str1, now you can see, now this is a counter, is a dictionary, and E is 3, and B is a 3, and C is a 3, D is a 1, okay, D is a 1, and then E is how many times here? 1 time, right? Now you can read this. You can read this key and values. For key comma value in a counter dot, what is that here? Items. For key comma value in a counter dot items. This will return items view. So where key is a string, okay, and value is a count here. Okay, so value is a count. You can see A3, B3, and C3, D1, and E and 1, right? Sometimes, for example, if you are working with some interviews, right? Yeah, this notes I'll be uploading in the, sorry, this notes I'll be uploading in the Google Classroom. Sorry, I'll be uploading this in my Telegram. This notes I'll be uploading in my Telegram. Okay. So this is my Telegram here. Okay, this is my Telegram ID. So what is my Telegram ID is some code with Satish Gupta. Right, this is my Telegram ID. So I'll be uploading this notes in the Telegram. Okay, this is my Telegram ID. Code with the Satish Gupta. This is my Telegram ID. After this session, I'll upload these notes. Okay, in the classroom. Okay. Sorry, Telegram. Right. Yeah, this is how it is. Now it is not only applied on the list and strings. You can apply this. Okay, you can apply this on list. You can apply this on the string, any iterable which implements which protocol, iteration protocol, which implements iteration protocol, you can apply it. Okay, yes. Or you can also use, okay, you can also use this on a dictionary also. So counter can be used on the dictionary. Okay, now this is counter with the, so counter with the dictionary, but what dictionary is having, so key and values, right? What dictionary is having key and values, but what counter will do, so counter, a dictionary has the elements as a key and value pair, right? And they are written inside the curly braces or curly brackets, but dictionary of the count, but what it will do is it will convert. Okay, so what it will count is, for example, if I'm writing, if you are using a counter with the dictionary, so what will happen is, so a dictionary has elements. Generally, a dictionary is elements has what here, key and values. It is having key and values as key and value pair. Dictionary is having key and value pair. Dictionary is having key and value pair. And generally, you know it. Dictionary is created using what? Curly braces. Dictionary is created using curly braces. Okay. Okay, right? So a dictionary has elements as a key and value pair. Okay, and dictionary is created using curly braces. Dictionaries, okay, created using curly braces. But what will happen if you are using this counter in a dictionary? So because see where the dictionary doesn't have a duplicate keys, but dictionary can have what here duplicate values, right? Dictionary cannot have a duplicate keys, but dictionary can have what here duplicate values. So what will happen if I'm trying to use this? If I'm trying to use this on a dictionary, right? If I'm trying to use this on a dictionary, suppose see here, because counter itself is a subclass of which one dictionary, right? For example, if I'm using a colon one, okay, b, okay, b colon two, then I'm saying c colon three, right? But in dictionary, can you add a duplicate keys? No. Suppose if I'm writing a colon two, so what will happen? The a key is updated with what? Dictionary. A key is updated with the value two. A key is updated with the value two. See here, A is two and B is two and C is a three. But what will happen if you are applying this counter on a dictionary? Suppose I'm saying C equal to counter. Okay, iterable. See, whenever you iterate, generally what will happen when you iterate? Okay, see here, dictionary one. I just write counter of dictionary one. So when I print counter here, when I print counter, so what happen? It is created with C is a three and A is a two and B is what here two. It is organized using which object? Hash table object or hashable object, right? Is it ordered or unordered here? Unordered. See the way how you store in the dictionary is A2, B2 and C3, but how it is stored in C3, A2 and B and 2. But it is a dictionary, but is it doing any counting here? No. When you are applying this, when you are using counter with the dictionary, what will happen is it will convert this. What will happen is it will convert this. Okay, it will convert this into an hashable object. It will convert this. It will convert this into which objects here? Hashable objects, right? So directly if you apply the dictionary, but dictionary is having two things. One is a key and one more is what? Value. So you can apply like suppose C equal to counter of dictionary one dot which one you are using values. Okay, dictionary dot values. Okay, dictionary dot values. Then it will count each value. Okay, each value. Two is there how many times here? Two times. And three is there how many times here? One time. But if you are applying directly a dictionary, is it any meaning here? No. In this self, it represents this as a key, and this represent as what count or value. This represent as a key, and this represent a count as or what is that value like that. Okay. So two, two, and three is what here one. For example, there is a some grade dictionaries there. For example, there is a grade dictionaries there which contain some name of the student, and having what here grade. Okay, so the name of the student. So this is the name of the student. Okay, I can say this is a grade. Then again, name of the student. Sorry, this is what is this here grade. Okay, and name of the student. Okay, and this you can call it as a grade. So name of the student. I take the, so this is a grade. Okay, name of the student, and this one is what here grade. So if we take this is a grade dictionary, I want to know how many students got A grade, B grade, and sorry, C grade. I want to know how many students got A grade, B grade, and one more is what here? C grade. I want to know how many students got A grade, B grade, and one more is what? C grade. Okay. Then I should count. What should I count here? Values. Now this is a grade count. Grade count equal to some grade, sorry, counter of, so counter of, what should I write here? Grade dictionary dot, dot, you're counting which one here? Values. Grade dictionary dot values. What you're counting here? Values. So when I print, now what I print here? Grade dictionary, yes, grade counter. Now you can see, sorry, the or I've written. So print. So if you say grade counter, so it is print A grade students are 3, B grade students are 2, and C grade students are how many here? 1. Okay. So you can apply this even on dictionary, but counting values. But if you are applying this on a total dictionary, so because when you are saying iterable, okay, so just convert that dictionary into hashable object. Okay, so print dictionary. So is it now if I apply this dictionary function to the dictionary to the counter, so it is displayed the same, but is it read each one as a hashable? And you can see C3, A2, B2, right? Yes. So print C, but this is counting values. Okay, this is counting which one here? Values. Now this is counting values here. So this is counting, sorry. Okay, this is counting values here. So I try to print it. Yes. So this is grade counter. So this makes it, I'm saying no, this makes it uh, development more easier. Rather than you write the code, just use the existing code. Okay, rather than you write the code. Okay, rather than you write the code, okay, you can use what your existing code. Okay, now see here. Not only that, you can apply this counter with the tuple also, because tuple is also one collection, right? So there is a tuple, some 1, 2, 3, 4, 5, 1. So 1, 2, 3, 4, 5. Okay, some 1, 2, 3, 4, and 5, right? So I want to count here. So C equal to counter, C equal to counter of tuple 1. So you can see the count of elements of tuple 1 here. You can read key and values in counter dot items. Okay. Now here key is nothing but a value of the tuple. Here key is nothing but value of the tuple. Here key is nothing but value of the tuple. Okay, and value is nothing but count. Okay, value is nothing but count. So key comma, I'm just displaying the value, right? So one is the value which is there 3 times, 2 is there 3 times. Now this is applying the tuple. I mean applying the counter on the tuple. So this is using counter on which one here? Tuple. So we use a counter on different types. So I said about list, using counter on list, using counter on string, using counter on dictionary, using counter on tuple. So any collection you can, any collection which implements, even you can use file also, because file is also iterable. You can use even file also, because file is also what here iterable, you can count. Okay, yes. Accessing, now next we'll see accessing, accessing and initializing, accessing and initializing. Okay, accessing and initializing, initializing and updating, updating which one? Counter. Accessing, comma, initializing, initializing, accessing, initializing, and updating counter. Accessing, initializing, and updating counter. See, generally, now till now, whatever we have seen, you are trying to initialize the counter. You can initialize the counter, right? You can initialize the counter by passing any iterable. Okay. Initializing counter. Suppose, for example, I'm trying to create a counter like this. Suppose some C equal to, I just write here counter. But are you done any initialization here? No. If I write C1, this counter is what now? Empty. If I say C1, now this counter is what here? Empty, empty counter it is. Is it this counter is having any key and values here? No, not having any key and values. Because of that, see, whatever you are sending this, you can call it as which one? Initialization. Means you are creating a counter with initial value, right? But how that counter is internally working it, so it is trying to convert that into one hashable dictionary. It is converting that initial value into what? A dictionary. Dictionary which contain the count of each elements here. If I'm writing counter of, okay, okay, suppose Python by some Gupta, right? So what will happen here? This is nothing but initializing it only. So what is initializing here? We are creating a counter with the initial value. We are creating a counter with the initial value, and this is initial value. What is the initial value of this counter? Python by Gupta, right? If I print this counter, sorry, if I print counter 2, if I print counter 2, so what the counter 2 print here? Sorry, if I print counter 2, what the counter 2 is printing? So it is counting, okay, it is initializing the counter by counting each element, right? This is called as what here? Initialization. This is called as what here? Initialization. Okay, this is called as a initialization. But once it is initialized, can you do any updation? Yes, you can add more. Okay, suppose C3 equal to counter. I'm trying to initialize this by using which one here? List. Some 10, 20, 30, right? So it means the counter is initializing is nothing but again counting only. Don't think something else. Now 10. So counter is initialized with a list of counting values. Now 10 is there how many times? One time. 20 is there how many times? One time. 30 is there how many times? One time. So this is called as initialization only. Okay. But you can also create which counter? Empty counter. You can also create which one? Empty counter also you can create it. So this is initializing. Counter is initialized. Counter is initialized, initialized, initialized by sending or by using iterable, iterable as input. Okay, iterable as what here? Input. As we is nothing but creating counter, creating counter by counting which one objects exist within iterable, exist within iterable, right? Yes. Now it will try to print. If I print C2, if I print C2, right? So it is printed like this. Okay, so initializing is nothing but creating counter only. So don't think that something else. Okay, by counting each and every element. Initializing is nothing but creating counter only, but by counting each and every value. So we can update the counter. Okay, you can update the counter. But how can you update the counter? You can update the counter by using a method called update. By using a method called update. It means counter is a, sorry, is it counter is a mutable or immutable? Mutable. Is it counter is a mutable or immutable? Mutable, right? So you can update the counter. You can update the counter by using count. What is the meaning of this? For example, say I already created one counter. Suppose C1 is there. C1 is there where I counted this list of values. Okay. I counted this list of values. Now this is C1 where this count is like this. 10 is 1, 20 is 1, 30 is 1 and 40 is 1. Now I want to update. What I want is I want to update where I'm saying C1 dot update. Now I want to count more. I said 10 comma 20 comma 30. I said 10 comma 20 comma 30. Now if I'm saying C1, now count is updated. Now this time, okay, already 10 is counted and what is the value of this counter? 1. 20 is counted and what is the value of this counter? 1. 30 is counted and what is the value of this counter? 1. 40 is counted and what is the value of this counter? 1. Now I updated, means I want to count more. Okay, so I'm updating the same count by adding one more list here. By adding one more list or by updating with what one more list of values. So already 10 is counted 1, right? Now you are updating with 10, 20, 30 means already 10 is there with how many times? 1 time. Now it is counted how many times? 2 times, and 20 is 2 times, and 30 is 2 times, and 40 is a 1 time. If I'm writing C1 dot update, if I'm writing 10 comma 60 comma 70, so already 10 is there with the count of 2. Now if you are updating it, now 10 is counted with updated with the value 3, and 60 is updated with 1, and 70 is updated with what again? 1. If I'm trying to print C1, now you can see 10 is a 3 times, and 20 is a 2 times, and 30 is a 2 times, and 40 is a 1 time, and 60 is a 1 time, and 70 is also how many times here? 1 time. So this you can call it as what here? Updating. So counter can be initialized and counter can be updated. But how you are updating the counter? You are updating the counter by using a method called which one? Update. You are updating the counter by using a method called update. You're updating the counter by using a method called which one? Update is there. Okay. Update is a method for updating the counter, right? Yes. Yes. Yeah, just to try to understand this. Okay. So even you can delete an element from counter, deleting element from counter, deleting element from counter. It means counter is a mutable now. Okay, counter is a mutable. You can delete element from the counter, right? So how can you delete element from counter? All of you, like online students, hello students, are you able to understand? I think you are not. Yes. Yes, online students, can you able to understand this? Okay, this is, yes. Okay. Okay, now this is how you are trying to do it. So you can delete even elements from the counter. So how can you delete the elements from the counter? You can delete the element from the counter. See, it is similar to dictionary. Whatever operations you are doing on the dictionary, you can do the same operations on what? Counter. Okay. Counter is a subclass of dictionary. See a note. Note is counter is a counter is a subclass. Subclass means what here? Child class. Child class. Child class means it is a child of a dictionary. Whatever methods are there in a dictionary, all the methods are inherited by whom? Counter also. Whatever methods are there in the dictionary, right? All the methods will be there in the counter also, because dictionary is a mutable and counter is also mutable. Okay. So deleting element from counter. Okay. So counter is a subclass or child class of dictionary. Dictionary and all the methods of dictionary, all the methods of dictionary applied are inherited, applied, or what is that? Inherited. Inherited by all the methods of dictionary are inherited by, okay, inherited by counter class. All these methods are inherited by which class? Counter class, right? Suppose you want to access the element. See here, accessing element, accessing element from what? Counter. For example, how you access the element from counter? By using key, right? Then because counter is a dictionary, right? Okay, suppose I want to know how many times 10 is there. Then well, I'll say C1 of what is the key here? 10. Now 10 is repeated how many times here? 3 times. I want to know how many times what is that? 30 is there. I'll say C1 of some 30. Then it will get on a count of 30. For example, there is a some C2 equal to counter counter ABC, some A, and B I've written, right? So if you take this is one stringer, now this is a counter. Now after counting how many times each element is there, I want to know how many times A is there. I want to read the value of A. How can I get the value of A? It is a dictionary, right? How can you read the value from dictionary? By using key. Now C2 of A means what is the value of A? 5. If I'm writing C2 of B, what is the value of B? 5. If I'm writing C2 of C, what is the value of C? 2. Means how many times A is there? A is there 5 times. Okay. And B is there 5 times and C is there 2 times. Okay. Counter elements, counter values can be accessed. Okay. Accessed using a key because it is a dictionary, right? It is a dictionary and you can delete. So deleting element, okay, deleting element or item from counter, from counter is done, using, you can use which keyword here? So delete keyword. So deleting can be done by using which keyword? You can sorry, you can delete it. By using which keyword here? Delete keyword. Can delete it by using which keyword? Delete keyword. Okay. For example, now this is counter. Now I created counter like this. Some C1, okay, C1 equal to counter of, so there is a list, contains some values here. I'm writing 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. Okay, some 1, 2, 3, 4, 5. Okay, now this is, assume that this is a list. Okay, this is a list. Okay, this is a list which contains this many number of values. Now if I'm saying print C1, so this is a counter, right? Now I want to delete one. Okay, delete. So how you delete it? By using key. I want to delete the count of 3, right? I want to delete the count of 3. So just delete the count of 3. If I say C1, right? So count of 3 is deleted. Suppose I want to delete count of 5. I'll say delete C1 of 5. Then it will delete the count of 5. It will delete the count of 5. Okay. So 1 is a 3 and 2 is a 3 and 4 is a 3. So because it is similar to dictionary only, it is similar to dictionary only, right? So yes, all of you students is very simple, and which makes it your job more easy, right? So when it comes to the frequency count, when it comes to the frequency count, when you're working with some statistical operations. Okay, not only that, there is one method is there called most common is a method of counter. So this will return, okay, this will return okay, most common elements. most most common most common elements from which one here? Counter list or counter, right? This will return most common elements. For example, I create a counter directly with the key and value. So I said here, suppose counter is there. So I just write here counter. So I'm creating a counter using dictionary. So a dictionary means, now you can say this is a the key is a some X is there. X is a key and 5 is a counter. Okay, now some Y is a key and 2 is a counter and Z is a key. Assume that Z is a key and some count. Okay, Z is a key and the count is again 2. I've taken the count is what again? 2, right? Count is a 2. Okay, then next one is some, okay, some P is there. I've taken the count is a 3. So count is a 3. Now like this, I created a counter here. So print C1 means, now this is a counter. Now I want to know the most common. Then what will I do is I'll say counter 1 dot most common. I just use most common of, I've just written the counter. Now n, what is n I've written here? 2. So most common, okay, most common is written as what? X is a 5 and P is what here? 3. Most common. See here, this method will return most common elements from counter list. Most common elements from counter list. So what it is written? 5 and 3. So X is a 5 and P is what here? 3, right? So that is most common elements. You can also read only elements. You can read only the elements. You can read only the elements from. So this will return. Yeah, most common, right? So C1, and here I created, so I'll just get C1 dot most common, and I just given the value as what here 2. Suppose if I say C1 dot most common of, if I say 3 is written 5 3, and what is that 2, that is xp, and one more is a y. Okay, C1 dot, if I write most common of 1, so what is it written? X equal to y. Okay, now you can also return the elements the way how you return the elements, but this method will return all the elements, but whose count is greater than 0. It will return all the elements whose count is greater than 0. So there is a method called elements. So this method will return. So this method will return elements counter whose count is elements whose count is greater than 0. Whose count is greater than 0. Okay. For example, see, if you are initializing, you can create a counter with a count as a negative also. For example, I'll say C1 equal to counter. Okay. So this is a counter with some 1 is 5, or 1 is 5 times, and 2 is a 3 times, and 3 is a minus 1 times, and 4 is 0 times, right? And 5 is some 2 times, right? Now this is counter. So assume that this is a counter. Now if I'm using e equal to counter 1 dot e equal to counter 1 dot elements, so this will return only the elements which are greater. So it return iterator object for, so for element means k in element, and if I print k, so it will get only, yes. Now you can see 1 1, yes, 1 is a key here, 1 1 1 1, and 2 2 2. Okay, and then see, this is nothing but how it is written this. Okay, it is written iteration tools dot chain of objects. Okay, it is written iteration tools of chain of objects, right? So it means 1 is there how many times here? 5 times. So what it is written here? 5. And 2 is there how many times here? 3 times. And what it is written here? 3. And 5 is there how many times here? 2 times. And it is written how many here? 2. So this will return the elements, right? How many times? Because 1 is the element, and counted how many times here? 5 times, like that. So that can be done. So that can be done by using the method called which one? Elements. So that can be done by using the elements method called which one? Elements. Elements is a method. Yes, online students, are you able to understand what I'm telling you? Please. Are you able to understand what I'm telling you? Right? Right? Online students. Okay. Okay. Is it useful or not? These collections are useful or not? Okay. Yes. Very much useful, which makes it manipulating existing collections more easy. This collections makes manipulating existing collections what? More easy. Manipulating existing collections more easy, right? Okay, right. Just to see here what I said here. Okay, just try to understand here. Okay, I said about this, but in this, so many things are there. Here, we are just learning only counter. So there is order dictionary, there is a default dictionary, there is a chain map, there is a named tuple, so there is a double-ended queue, and there is a user dictionary, there is a user list, and there is a user string. So a lot of operations are there in the counter or not? Yes, right? So because of this time constraint, right? Okay, now today I able to cover only one collection. I mean one collection. What is that collection here? Counter. But in the next class means next workshop, maybe this week, next week, I'll try to cover most of the things like ordered dictionary, default dictionary, chain map. Okay, these things I'll try to cover it so that within 2 3 workshops, okay, you'll be completing all collections module, right? So in the next workshop, we'll be talking about like other collections like ordered dictionary, default dictionary, and chain map and named tuple like that. And after that, we'll be talking about DQ, users dictionary, user list, and user string. Okay, I hope you understood today's workshop, right? What do you say, online students? Okay, right. So in the next workshop means maybe in the coming week, this coming week we'll have again next Saturday or Sunday, coming week, we'll have one more workshop where we'll be talking about other collections. Okay. I hope you understood today's class. And these notes I'll upload in Telegram. This is my Telegram ID. So that is code with the Satish Gupta, right? So after this class, you can just see in the Telegram. I'll just upload all these notes, right? Okay. So thank you for joining. Okay, thank you for joining because of some time constraint. So I just taken only 1 hour, 20, 1 hour, 15 or 20 minutes. But in the next class, we'll have more. Okay. Yes, we'll just stop it here and we'll continue in the next workshop. Right. So thank you very much. Okay. Right. Thank you.